Hey guys, welcome back to another video, and today let's do some basketball physics. I was really inspired the other day when I watched the 2002 state conference final between the Lakers and the Kings, when I saw Horry pick up the basketball and shoot his buzzer-beating, game-winning three-pointer. I mean, it was epic. So, when I saw that shot, it really got me thinking, how much force must a basketball player put to make a three-pointer? Well, of course, we must first take some assumptions. In this case, we'll be using a high school basketball court, which means that the hoop is going to be 10 feet high, and the distance from the basket to the center of the three-point line is going to be about 6 meters. And since we're also going to assume that our shooter is a high school female, meaning that the ball is going to weigh about 19 ounces. So, if we correlate that with some numbers here, here's delta x, the distance traveled in the x direction is 6 meters, our final position must be 10 feet, which is about 3 meters, and 19 ounces in kilograms is about 0.53864 kilograms. Now, we need a few more variables. We need to find out the initial jump of the shooter and how long the ball was in the air for. Luckily for this, I analyzed the video, and if you guys want to see it, it's in the link. It's in the description below, and it's, I believe, the third shot attempted, and it's the first shot made. So I used that specific shot to find that the time the ball was in the air was 1.171 seconds, and the height that she shot from was about 1.575 meters. So, anyways, let's get right into the calculations. So, we have two different models. We have a constant acceleration model in the y direction, plus x naught plus x plus, and we also have a constant velocity model in the x direction. Now I'm just going to go ahead and plug in some variables. We know that g is 9.8 meters per second squared due to us being on Earth. We said that the time was 1.171 seconds for the ball to travel in the air. We do not know the velocity in the y direction, but we know that the time is 1.171 seconds, and this is y, sorry. And we know that the shot was made initially from a height of 1.575, and it was made at 3.048 meters. Alright, and then for our second one, when we plug it in, we have our velocity in the x direction, which we do not know, our time again, and that's going to be equal to 6.01 meters. So, if you notice, we have one variable here and another variable here. We can easily solve using some simple algebra. I won't do that here, but I'll just go ahead and write down the answers. 5.1324 meters per second in the x direction, and 6.4937 meters per second. Alright, so now we've solved for the velocities in those respective directions, and I'll rewrite it here so it's easier for me to do some more calculations. Alright, so we know that initially the ball was at 0 meters per second. It wasn't moving. So we need to find out the acceleration in the respective directions. So we know that Vx initial, which is 0, plus the acceleration in the x direction times the time it took to accelerate is going to give us our final velocity in the x direction. Same thing with the y direction. So when we plug this in, we get that ax 0.2 equals 5.1324, and AOY 0.2 equals 6.4937. And if you're wondering where this 0.2 comes from, using Logger-Pro, I had to find another variable, and it was how long it took for the shooter to jump from 0 meters per second to the moment she let go of the ball, and it took a total of 0.2 seconds. So that's where the 0.2 comes from here. So if we go ahead and solve this out, we get that the acceleration in the x direction is equal to 25.662 meter per second squared, and the acceleration in the y direction is 32.4685 meter per second squared. Alright, now we have to take into account one more thing, and that's we live on Earth. And because of that, we have to counteract gravity. So here's our actual acceleration in the y direction, and we have to counteract gravity, which is 9.8. And that's supposed to equal our acceleration of 32.4685. So what we do is we say that AY is equal to A real minus 9.8. And since AY is equal to this, we can just use some simple algebra again to get that our acceleration in the y direction is actually 42.2685 meters per second squared. And again, that's because we have to counteract gravity. Alright, now since acceleration is are vectors, we can just simply add these two vectors using the Pythagorean theorem to get the resultant vector for acceleration. So if we do that, our acceleration is going to be equal to 49.4486 meters per second squared. Now to find force, we just simply do mass times acceleration. And again, we're finding the average force throughout the shot. So obviously force will vary throughout different points in the shot, but overall this is a pretty good depiction of how much force is needed to make a shot. So the mass of the ball was 0.53864. We just multiply it by the acceleration received, and we will get a final answer of 26.63 newtons. So looking back on this, just to do a quick recap, to make a shot from 3-point range, implying that you are a girl at a high school shooting a 19-ounce ball, well, you will only need to make 26.63 newtons of force to make the shot. And that's about 6 pounds. So yeah, hope you guys enjoyed.